So after this very nice overview of PyScript, we're going to go a bit more in detail and see what is necessary to actually take a package and run it in the browser, for instance, in PyScript or in other environments. So myself, I'm an ML engineer, or where I do consulting work at Cimerio, which is a company based in Paris. My background is computational physics, and I'm a maintainer of Pyodide, and previously I was working on scikit-learn. So in this talk, we're going to introduce Pyodide in a bit more detail, which is a build of CPython for the browser. And we're going to explore the topic of how can we optimize the Python packages or Python applications to be smaller and load faster on the web page. So just a brief slide on WebAssembly. So as you already saw, WebAssembly is this binary instruction format which allows you to run, like for instance, code in C inside the browser. So it's portable. It doesn't depend on the architecture. It's secure, and then you can run it, for instance, in the browser or in Node.js. So because it allows you to run arbitrary applications, in particular, you can take the CPython interpreter and run it inside the browser with this technology. And of course, if you want more details about this, please stay for the follow-up talk by Antonio. So what is Pyodide? Pyodide is we take the CPython interpreter, we compile it to WebAssembly using Emscripten, which is this build toolchain which allows you to do that. So since last year, CPython also has tier 3 WASM support. So now it's a build target which is to some extent supported by CPython. In addition, what we have is a Python JavaScript foreign function interface, which allows you to make calls between Python and JavaScript. So from Python, you can call JavaScript objects, and from JavaScript, you can call Python objects. So this is, for instance, what you saw in the examples of PyScript, where you interact with, for instance, the DOM or things like this. And in addition, we build a number of packages for this target platform. So for instance, here I illustrated some of the scientific Python packages, but we have a fair number of those. They are distributed with the JSDeliver CDN, which is a CDN, which is an open source CDN used mostly for JavaScript historically. And we can also install things from PyPI, which are, assuming they are pure Python wheels. Now, what is actually involved in building a Python package for the web? So if you have a pure Python package, the good news is you can just use it as is. So assuming it has a wheel. So if it has a wheel, so the file extension would look like something like this. Then you can just load it with micropip, and it should work, assuming it doesn't use unsupported functionality in the browser. If you have a Python package with C extensions or Rust extensions, which is the case, for instance, for scientific computing packages or like a fair amount of packages in Python, then you need to cross-compile it for this target. So similarly, essentially to any other platform, you need to compile it somehow. There are two ways of doing this. The first way, for instance, is by adding it to the Pyodide distribution, which involves writing a meta YAML file, which is fairly inspired by Conda. And if you do that, then you will be able to use it through Pyodide. The second way is using Pyodide build, which is this new tool that we designed, which is essentially wraps PyPI build, which is the standard way of building wheels on Python. And it allows to build wheels for this platform. Hopefully, we have very soon we'll be able to do this with CI build wheel, which is a CI project that allows to build wheels for different platforms in CI. And while it's not yet possible to upload such wheels to PyPI, there is work in progress to make it happen. Of course, this is the ideal case. This allows you to have a wheel, but then the question is, will it work in the browser? If it's just your code does just like pure Python, pure calculations, for instance, it will work. If it uses some functionality which might not be supported in the browser, for instance, it tries to access sockets or it tries to create subprocesses, that will not work. So in that case, you will have to apply some workarounds for your package to make it work. And I would also like to mention that Pyodide is not the only project that does this. There is also Emscripten Forge, which is an initiative to also build packages for the WASM. but more inspired by Conda Forge and that aims to be eventually integrated there. A few words about the foreign function interface. So this is an interface that allows you to communicate between JavaScript and Python. So for instance, you can use JavaScript objects from Python if you do this import JS. So from JS you can import things, and those are essentially the JavaScript functions or objects that exist. And you can call them from Python. So there's automatic conversions of simple native types, and then other more complex types are proxied. And on the other way, in JavaScript, you can essentially call Python functions with this this way. So this allows you to essentially kind of merge the two ecosystems together by using things from JavaScript or from Python interchangeably. And if you want to learn more about this, you can have a look at our documentation linked below. So there is now a growing ecosystem of projects that use Pyodide. So we saw this morning PyScript, a very nice presentation. There's also, for instance, Jupyter Lite, which is a build of Jupyter for WebAssembly running exclusively in the browser. And this has also very large implications, for instance, for teaching. So this is like a really easy way to deploy notebooks for teaching without having to maintain any infrastructure. And for instance, recently there's also been added support to things like Things Gallery, which is this way of adding interactive examples to the documentation. So for instance, if you take most scientific Python packages, they use this package to have examples. And with this approach, you can essentially have live example that you can run in the documentation. So previously, this is currently done with Binder, and it works well. But however, the problem of Binder which is a hosted instance of Jupyter, that somebody needs to pay for it. And while with this approach, essentially, since the computation is client-side, you don't need to do that. There is also other interesting initiatives. For instance, there is the React project, which aims to integrate essentially Python code in the React apps. And there's also a number of dashboard applications. So we have, for instance, that are written in Python. So for instance, you have Streamlit, you have Plotly Dash, and you have Voila in Jupyter, which allow you to have some kind of interactive dashboard written in Python. And traditionally, this requires you to run a server that will interact with this dashboard, which is potentially a bit problematic to deploy. You need to keep paying for it, etc. And recently, there was an effort to make these dashboards also in a version that runs in WebAssembly. So you can just have a static file, and then your dashboard will be interactive. It will still be in Python, but you will not have to host anything like a server that runs permanently. Now, we have seen a bit a quick overview of Pyodide, and now let's look a bit on the topic of size and load time, which is a fairly important subject in the web. So the situation right now is that essentially, if you are running Python, you don't really care that much about how big packages are or how much things are being downloaded to your computer. I mean, as long as it's not gigabytes, it's fine. What we have is that we have a fairly large packages with a lot of code, with sometimes things that are not necessarily critical to run. So for instance, some projects will include tests inside the package they distribute because it's just convenient. You can run tests with your package. It's very nice. But then in the browser, you end up loading a lot of things that you don't actually need, which will impact your load time and your essential user experience. So for instance, on the right, you have an example of loading pandas in Pyodide. You can see that while it had to download 18 megabytes, and then it finished in 15 seconds. I mean, this is probably might be okay for some kind of application. So for instance, if you do teaching and you have a room full of students, that's fine. I mean, that allows you to do things and it's okay. If you are on a high traffic website and you just want to do a small dashboard that uses pandas, that's not okay because you don't want to download such amount of data just for a small dashboard. So the question is, of course, what can we do something about it? And it's worth mentioning that the browser is not the only resource-constrained environment where things can be run. So you have also projects like MicroPython, which allow you to really shrink the size of Python, like have Python code run with much less size. But then the limitation is, of course, that you do not have access to the full ecosystem of Python packages that you might need to develop your application. So what can we do about it? There are many directions that could be explored. So one topic is compression. We can say, okay, we have all those files. Let's just compress them better. We'll talk about this. The other thing is, well, can we just transform the source code somehow to make it smaller, or less, or remove things maybe, etc. Maybe minify code. So, for instance, JavaScript will minify code. Can we do that in Python? And the final topic is bundling, which is we take a full application and we only keep things that we actually need. We only keep the files we actually need and maybe only the functions we actually need. So again, in JavaScript, this would be tree shaking. Is it possible in Python? That's a question. So in this figure, you can see some of the things that were already implemented in Pyodide. So for instance, we already do CDN compression or unvendering tests, but other things still need exploration and more work. So let's talk about compression a bit. So all the Python packages on PyPI are wheels, can be distributed as wheels. And those, by definition, are essentially zip files. In zip, you have the deflate compression, which is OK, but it's not optimal either. On the other side, the peculiarity of this WASM subject is that we are essentially running in the browser, and we are getting files from the CDN, so this content delivery network. And the content delivery network can apply compression, which will be transparently decompressed by a browser. So the nice thing about this, it can allow you to do a bit better compression than what is provided in the zip files. So in particular, Brutally is quite efficient. It's really good for Python source code and WASM files. So for instance, on the right, you have this an example of compression ratio for standard library, for the Python standard library. If you take the Python files, it's like, for instance, 4 times with gzip, and it's going to be 6 times with Brutally. And WASM is also optimized to be well compressed by CDN. For the Python bytecode, the situation is a bit more complex in sense it is compressible, but it was never really designed to work well with compression. So that's not a use case that was like anybody had in mind. And so it's possible that if we add some additional domain-specific compressor or like pre-compressor before the CDN, it will improve things. But this will need this will require going quite deep into the CPython internals. Another thing to keep in mind, if you do your deployment yourself, is that actually if you take a wheel, which is a zip file, which is compressed, and then you recompress it with the CDN, it will actually make things worse, because the CDN then will not be very efficiently compressing things. So what we do in Pyodide, for instance, is we disable the compression in zip files and only use the CDN. Another thing you can do is try to reduce the code size, and this could be done with abstract syntax tree transformations. So there are many things you can do. For instance, if you take simple things, you can just remove comments. So there's a lot of comments in some projects. For instance, in the example of standard library, there's 27% of comments. Then you can group imports. I mean, those are the kind of things that linters do. You can also normalize parentheses, single, double quotes. So this doesn't really matter if you don't compress, but once you compress, it helps. And then there are more other things you can do that will help, but they will also lose, make your code a bit less Pythonic, or you will lose some usability. So for instance, if you remove doc strings, again, for some applications it's fine. If you're doing teaching, that's not okay. And even more, if you really do want to do minification, well, you can start like renaming locals to be shorter or even globals, but then this potentially can break things, and that's really not good for usability. But is the package load time only the size? And it turns out that no, because if you look what's involved is essentially you have the load time, and then depending what you distribute, many things happen. So if you have just Python files, the source code, what happens is they need to be parsed and compiled by the Python interpreter into PyC files before they are run. So normally in your Python installation, this is done at install time, but because in the browser you do both at the same time, well, essentially this has to happen, and it takes some time. Or alternatively, you can distribute PyC files, which are then faster to load and faster to import, but then if you have some errors, you will not have code snippets inside. And we cannot distribute both because it's heavy. So currently we have separate builds for Py and PyC files, but it's a choice. And then WebAssembly, well, it was compiled already for, so your application was already compiled to WebAssembly. It actually needs to be specialized in the browser, so compiled with a specialization to the target architecture. This is fast, but it still takes a bit of time. And so as a result, if you take, for instance, depending on application, well, these different points might impact differently your runtime. So for instance, for scientific applications, point 3 is more often a bottleneck. And even further, for instance, if you look at import time in standard Python, so you know some packages takes a while to import. And this has been optimized, there have been effort to optimize this, but you have to keep in mind that also Python in the browser is a bit slower, so it can be slower by a factor 2 to 5, I mean, depending on the code. And so, for instance, if you take pandas, pandas on your computer is going to take 0.05 seconds to import. Well, you multiply that by a few times, and then you'll end up with just a few seconds due to import time. So optimizing import time in your package is actually important because in the browser it will be worse. And then you can do different things, such as try to remove the modules that are not necessary. So if you really want to, you have a given application, you want to optimize it, you just remove the modules. For instance, doing dependency parsing of modules, you have the standard library called Module Finder, which essentially finds import in your application code, computes the dependency graph, and then you could only put those. But the problem, of course, is that there are a lot of things that are optional. So for instance, in pandas, the toParquet method is if you use that, you will need PyArrow dependency. But then if you don't use it, you will not need it. So your dependency parser need to be able to understand that. And worse, Python is very dynamic, so you can do a lot of things dynamically, including imports, and then these approaches will break. And also, this doesn't really extend to non-Python code. So for instance, if you look at shared libraries, so some packages will need shared libraries, this will not work. Of course, this is not a problem only for WASM. Any kind of bundler that produces a single application for Python has this issue. So for instance, you have PyInstaller or Py2app. Those have a bit of the same challenges. The specificity of the browser, however, is that we are essentially not only shipping Python, we're also shipping the OS. So Emscripten provides all the OS layer, let's say, which we can relatively easily modify. So in particular, it's possible to say, okay, well, can we just intercept all the file opens, like all the files that were being opened in an application, and only keep those. So this is what is done, for instance, in the Pyodide project. Package which essentially you will give it example of code. It will parse. It will try to run it inside the browser sandbox, and it will see what are the files that are being accessed. So this, for instance, in the example of pandas here, will allow you to have some reduction, but it's still not like a 10 times smaller final application. And the reason for that is we often have top-level imports in the code. So for instance, here's an example of pathlib, where here are the imports that pathlib does. And you can see that while some of those are probably very necessary, others are like very specific. So for instance, regular expressions are probably only used if you do some globbing, or maybe like ntpath is probably not used at all in the browser, and then stat is going to be used only if you do some stat, if you do this status of the files, and then you really parse it again. So all of this is very, like we put all the imports at the top, and then a lot of things are not used. And if you multiply that by hundreds of files, well, you end up with just including everything and having large applications. So of course, we cannot change this style because this is essentially specified by the PEP, and it's like too late to change that. But what we can do is see if there are other approaches to mitigate this. So for instance, you have this PEP which proposed lazy imports. Which essentially propose to make imports happen only when they're accessed. And this would actually improve things, but unfortunately that path was rejected. And we can go in further, is saying, well, in the browser, the installation time and the import time is a bit less, there's this less strict boundary between them. So for instance, if you do in Pyodide, you do a Pyodide run Python async import NumPy, what will happen actually is it will first install NumPy and then run it, and then import it. So could we just consider that we have some remote file system, and then we do just load files as needed from it? This is currently not possible because we cannot do this synchronously, but it will be possible with the JS Promise integration once it's like added to Pyodide and enabled in browsers. But there is still probably a problem of latency because you have, you know, again, import pandas accesses 450 files. You add some latency on each request. I mean, it's going to be huge, even if you do things in parallel. However, this might give you some ideas of some things you can try, like if you load only a small subset of the files you need, or maybe on errors, etc. So in conclusion, Pyodide now is a project that was started 5 years ago by Michael Drotboom at Mozilla. It started really experimental, and now we have essentially a lot of things that got stabilized, that matured. So we have official CPython support, and there's a growing ecosystem of things building on top of them. We have also so this new technology allows a lot of different use cases that were not possible before in education, in like privacy-preserving applications, etc., and like makes Python available to a new category of users. In this particular case of reducing the size of Python application, this is a fairly challenging topic. So we are working on developing some tools, but some things might need also effort, community effort, to make the Python ecosystem more web-friendlier, because this was never really a concern before, right? This was not something we thought before. Of course, here I presented only a single topic, technical topic of reducing the size of Python applications for the web, but we are working on a lot of other things in Pyodide, and you can find them in our roadmap. And we are also welcome new contributors. There's like, because it's fairly still a new topic, you know, the WASM, Python with WASM, there are a lot of low-hanging fruits, so there's a lot of things where it's easy to start. I would like to acknowledge a lot of the maintainers for the Pyodide project, people who contribute to Pyodide, our sponsors, and then the broader community of projects that we depend on, Emscripten, CPython, JS Delivery CDN, and downstream projects, so JupyterLite, PyScript, Baston, Iridium, Iodide in the past, etc. And we also had very helpful discussions in the WASM Summit about some of these subjects at EuroPython a few days ago. So thank you, and join us for the sprint this weekend.
Thank you so much, Roman. There was no question in Discord yet. One statement. The statement was that panel package has been seen running in the browser. I will use the moderator privilege and ask you one thing. What is the most interesting thing and the most complex thing that you have seen running in the browser in Python?
Complex and interesting?
Yeah.
Well, I mean, complex, I would say, to some extent, even if I'm a maintainer, I'm still kind of surprised that all of this is even running and possible. Interesting, I find like there's a lot, like, so PyScript, there's a lot of exciting things on that side. And I also find that there's a lot of exciting things for education. So making things possible to learn Python without like all this complexity that's usually involved with packaging or installing things.
Thank you, Roman. I think we have one question here up front.
Is there an equivalent to subprocess run? So can I have like an executable that's also run in WASM, use something like subprocess to start and get the output from it?
Yeah, I mean, basically it's web workers, so that's what we saw before. But there's some idea to like implement some. I mean, it's not exactly superprocessing. Like there's some idea that you could implement a multiprocessing API on top of web workers, but like it hasn't been done yet.
Yeah. Okay. Thanks.
Thank you so much, and we can continue with the Q&A in Discord and in the hallway track. Thank you so much once again. Oh, sorry, I overlooked you in the back.
Yeah, no, I just got here.
Please.
So my question is, what do you see the future of Python in the browser to be? Like, given that well, Python has a huge it's way behind JavaScript in many things running in a browser. How do you see the future of Python in a browser?
Well, I think it's behind, so it's not going to replace JavaScript, in my opinion, right? Like there are still use cases where clearly just the size is going to be a limiting factor, but it just like it will allow some applications that were not possible before. And like for instance, if you have backend code written in Python, and there's a lot of legacy code written in Python, it will just make it much easier to make it accessible to users without having to develop some kind of web service, etc.
Right. Even if it's like. Performance-wise, not
yeah.
Right.
And I mean, performance is going to improve. It's just like also a matter of time, a matter of resources, etc.
Yeah. Okay. Thanks.
Next question, please.
Thank you for the presentation. I have the following question. You mentioned that we will be able to call JavaScript from Python and vice versa. What do you think? Which limitations will we have?
Okay, so I'm not the best person to talk about this. Hood is somewhere, might be in the room, but not the maintainer of Pyodide. But essentially, one limitation is that you have the memory management between Python and JavaScript is not exactly the same. And so right now we have ways of managing it, but it requires a bit more manual effort to do that. So that's like the ideal, like one of the limitations. I mean, the other, yeah, that's probably the main one, I would say.
Thank you.
Another question in the back, please.
Thank you for the nice talk. I was wondering about the integration with the graphical part, graphic libraries, by Qt,
Yeah.
by Qt Graph or...
yeah, so I know that, like, for instance, Qt people are working on building Qt for WASM. I don't think there is a like Python build for that yet, but it's, I mean, for Qt, for instance, it's just a matter of like build time because building Qt is really challenging. We have, I think, we have the pixel integration in Pyodide now, so you can make some simple games with it. It's possible. It's just a matter of effort and resources and things like this.
Okay, thank you.
We'll need to conclude this session. Thank you so much once again, Roman.
Thank you.